Hello, everyone, and welcome to another MLOps single engineer group update, this time for November 12th, 2021. Welcome back, and we're going to talk about some very exciting things this week. Just a reminder of what we're doing here. My vision for this MLOps is just to make GitLab a tool that scientists and machine learning engineers love to use. The thing is, especially data scientists, they don't use GitLab because they want to, they use because they have to. GitLab and Git and the CI isn't really compatible a lot of times with the data scientist workflow. And we are trying a little bit to bridge this gap and see what is the tooling that is missing, what are the components, how can we make GitLab a better companion for data scientists. So on that note, first, yay, Jupyter Diff is live. We finished most of the first iteration of it. You can see it over here. It is not perfect. It is not ideal. That was never our goal, but it is better than before, a lot better. So now you can clearly see what changed within the Jupyter Notebook. You can clearly see the differences. We're still, there are a lot of things we want to do over here, but the first iteration is live and users can already see it. It's going to be for the self-managed customers, it's going to be on 14.5. For GitLab Con users is already over there. And hey, very happy with the results. We shared this on Twitter, and the results, the reception by our customers was really great. They were very happy with this, very excited. Both GitLab users, our competitors, were looking at this as well. So I'm very happy with it. We'll still be working on it. There's still a lot of things, like I said, we want to do. And if you have any asks or any feature requests, any feedback, I will link this this issue on the video description, so you can just come in, give your suggestion. I will take a look, and then we can discuss. Then I can see what I'm gonna do next. But very exciting, very happy. Finally, it took 2 months, but it's out there, and yay. Okay, next one. Done that. Taking that off the out of the scope. Now, the other thing that we're working on, we are both looking at feature implementation, which is the Jupyter Notebook, but we also want to explore how data scientists could use the things we already have on GitLab. One of the aspects that data scientists, machine learning engineers do is that is part of the machine learning process is to optimize the hyperparameters of the model. Hyperparameters are just the parameters you pass to the model itself, not to the training. So when you create a model, you can select a lot of configuration you can tune out a lot of the configurations for the algorithm, and these are called hyperparameter. And this configuration can make an impact on the model performance. So this is what we call hyperparameter optimization, is in an additional step to the training pipeline where you train with the data, but also choose what are the best hyperparameters for your use case. And this is a very long, tedious process. You run many times the model, and using pipelines for that, I usually the way to go, either with Kubeflow or AWS SageMaker. And here we want to explore a bit how can we use GitLab for that. This is not the common use case for GitLab pipelines. We understand that, and it's more about exploring how could this be made better, and can we use this as it is right now. So to be able to do that, the code is like, this is the issue, but over here. Okay, so what I did, instead of picking up a data set or anything that's out there, what I did, I created a simple model that has 6-7 random variables, and that I compute a function that returns true or false based on this 5 or 6 the 7 variables. Then I remove three of these variables, which I call features, which means that I'm trying 7 features are necessary to create my target for prediction, but I only have 4 available. So I can use machine learning to try to estimate the value of y based on A, B, C, and G. So it's a very simple way of creating a model for a data set that I can control. Our focus here is not really the data set itself, is how to explore the pipeline. So it was okay for now. So what I did over here, I created a pipeline over here that, okay, this what? Here. The pipeline itself, SEG pipelines. Editor and the visualize. Okay, so what I did, I created a very simple pipeline that first of all fetch the data, which is the step that I shared just to create a data set and create an artifact. Then it optimizes the hyperparameters. I use sklearn for this, and I use a very simple algorithm for the hyperparameter optimization. The optimization steps are basically a search problem. You have to run a search. So one of the ways is to test out all possibilities and choose whatever is best. This is what this algorithm does. So it's very simple, not optimized. You can do a lot of training with this, so you cannot go crazy on your hyperparameters, but it is a first skeleton, so that's okay as well. And then the next step, it publishes the results to the merge request. So if we come here to this is the visualize, but I can come to the merge requests, and I can see a very simple merge request that I added. So hello, it doesn't really matter, but if you come over here, it reads this file of where is parameter? It reads from this file, the hyperparameters.yaml. So there are many parameters that I can configure on this model. And then I run this pipeline over here. So we can look on this step, optimize sklearn job. And you can see over here that it's running many tries. So it tries all possibilities within that specific scope that I gave. Not only that, it tries many times because it uses cross-validation to score the models. So for every configuration that I have, it tries 5 times with a different training set. This is to make sure that the data, that the score is compatible with, like it's not just one case where it went really well. No, within that hyperparameter, those are the best results, for example. So for example, for this one, it tests 5 times with different training data for max depth 2, max samples 500, and samples 10. And it does for everyone. So if you look at here, I just had 12 candidates, but I only had, where is the hyperparameter tuning? And then over here. So I only tested 3 values for max depth, 2 for max samples, and 2 for min sample split. So that means I only had 12 possibilities, but in the end, there were 60 model fits. So it takes a lot of time to compute this. Not in this case, which is very simple model, very little data. I didn't care so much about that, so it's very fast, but think that this can explode very quickly. This is why it's important to have this as a pipeline. And this is a limitation of this one, with this is run sequentially. Ideally, this should run in parallel because they're independent of each other. So I can just go crazy and fire 5, 6, 7 concurrent pipelines so that I can get results faster. After the pipeline, this optimization pipeline runs, then it's the next step, which is publish results. The published results just takes all the tests that I ran. So there were 12 possibilities, so 1, 2, 3, blah, 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 12, and it ranks. So I can see that the best result for this set of parameters is with a 10 of max depth, 500 max samples. I will not go over what this means. This is another video entirely. but there was a difference of 2% between the worst and the best model. So it seems small, but when you are doing machine learning at scale, that actually is a lot of difference on the results. Think that you are running this on a recommendation page. If you get 2% more of conversion, just because of this, that's insane. So now what it does is just it creates this report, and that's it for now. It doesn't do much more than this. But that doesn't mean that's all. That's where we want to stop. So if we come back over here and over here, and no, not this one. This is the skeleton. This is the starting point where we want to start getting more and more complex. So first of all, there are many things we can do, but we can use real data instead of the fake data that we're using. We can implement an iterative pipeline. So there are algorithms for optimization that are not try everything. They are more like, let's try this 5, check the results, and then come up with new 5 values, and so on and so forth. Really a search problem. We can use this to stress tests. So suppose that you are running TensorFlow and really large data sets. How would a GitLab behave? Well, how would the runners behave with this? So let's try this out as well. GPU runners that we have available. And one other thing is the building experience. So it's really not nice to build GitLab pipelines. It's not horrible, but it's a lot of trial and error. But is it possible to make it easier? For example, can you transform a Jupyter Notebook into a pipeline? User pushes a Jupyter Notebook and that becomes a pipeline. We can try that. So if you have any idea, anything that we want us to try it out, I'll add the comment over here for the experimentation for the epic. Share with us. We will try to look into, we will give priority to suggestions, to external suggestions. And yeah, that's it. Thank you very much. That is for today. Bye.